We have a few more minutes to answer questions, so let's go back to Jeff and get some of those questions that you left for us. Get them answered.
All right. Well, this is we're going to go into a science direction now, and I always get confused about this because I never quite understand this stuff. So this will help me out too. But this is a science question. It says, "Is a liquid with a pH of 10 basic or acidic, and how do acids and bases differ?"
Sure. Well, let's answer the question first, and then we'll explain why that's the answer. So we could jump to my screen. So the pH scale is a scale that we use to measure acidity and alkalinity or basicness, how basic something is. So on the image that I have on the screen is kind of useful because it gives us this scale. It tells us that the scale goes from 1 to 14. And it shows us that anything below 7 is considered acidic, and anything above 7 or 8 here is considered basic. And then 7 and 8, roughly at that range, is considered neutral. And then it gives us some examples. So like very acidic, something with a pH of 2 is going to be your stomach acid. Tomato juice actually has a pH of 4. A lot of us probably don't feel like tomato juice is so acidic. So you can see kind of how quickly the scale sort of moves up. Pure water, for good reason, is neutral. If you have a cup that is only water molecules, it's completely neutral. Now, most of the time, though, when we drink water, it's not pure water. It has other things dissolved in it, which might make it more acidic or more basic. You can see there, human blood is slightly more basic than pure water, but it's pretty close to neutral. And then hand soap actually hits the exact basic level that we were asked about in the question. So is a liquid with a pH of 10 basic or acidic? Well, it's basic. And you can see bleach gets to be more basic. And intense acids, so low pH stuff, 3, 2, and especially 2s and 1s, and then high bases like 13s, 14s, tend to be really damaging, and essentially for inverse reasons. And the idea is essentially this. So acids are proton donors, and bases are proton acceptors. And in the cases of really intense acids, they're just very aggressive proton donors. And in the cases of very intense bases, they're just very aggressive proton acceptors. In a way, they're like proton thieves. And we can sort of, here's a really simple drawing to sort of show. If you have an acid, they're really willing to give up protons, and bases really want protons. And then this image also keys us into a really key concept about acids and bases, which is that when we talk about protons, what we're talking about is really hydrogen ions. So the most basic element of all is hydrogen. And a neutral atom of hydrogen, and I'm not going to get too much into the structure of atoms right now. I've talked about that in other places. And if you have any questions, please call in. But presumably, if you're asking about pH, you've done a little bit of this work. So a hydrogen atom, a neutral hydrogen atom, has just 1 proton and 1 electron. When a hydrogen atom loses an electron, it becomes an ion. H plus is what we call it. And it also, being so basic, it's literally just a proton, just sort of floating around. So then I can give this other example here. If we could jump to my screen one more time. When we mix acids and bases together, what we get as a result are salt and water. And a really classic example is the mixture of hydrochloric acid, whose chemical formula is HCl, and sodium hydroxide, which has a chemical formula of NaOH. And so the key here is that hydrochloric acid has these extra H's, and really what hydrochloric acid would like to do is dissociate or break up into chlorine ions and then let go of a lot of its hydrogen ions. The base over here, sodium hydroxide, NaOH, it has this OH group, which we call a hydroxide group. A hydroxide group would really like to take on another hydrogen and become 2 H's and 1 O, which is H2O, which is water. If we have a situation where the chlorine can give up its H and give it over to the OH, and that can become water, that frees up the chlorine ion, which will become a negative anion, and the sodium ion, which will become a positive cation. That frees them up to join together and to become a salt. And definition of a salt is something that I don't quite have time to get into right now, but suffice it to say that when we mix acids and bases together, they will find equilibrium, and we will end up with pure water and a salt. And something that is actually drinkable, right? If you drank hydrochloric acid, bad things would happen to you. If you drank sodium hydroxide, bad things would happen to you. But if you drank the mixture of hydrochloric acid and sodium hydroxide, it would just be salt water. It would be gross, but there would be nothing wrong with it at all. So, in any case, long-winded way to say a pH of 10 is basic.